implementation in Plonky3, the Rust library.
Okay, so I'm gonna be short. I will talk about everything previously has been said and explained, from like the XMSS signature scheme to the minimal VM and all of this. So I will try to speak about like open problems and what we have been doing, like more on the code side of things. So we have several works fronts. One of them, the first one, the most basic, is like the signature scheme implementation. So going from the papers that Benedict just described, like to a Rust code. So there is this repo. There is also a very useful repo that contains all of the primitives that we are using. So basically the fields, the Poseidon hash function, the R constraint builders, and all of this. So Plonky3. Then we have the weir repo right now that is on a separate repo, but soon to be upstream to Plonky3. And then we have this leanVM multisig repo where all of the logic of the leanVM is implemented. So I will try to decouple the open problems on these different repos so that you can have a better overview of what needs to be done and what will be done in the coming months. So first we have this XMSS signature repo that is quite feature complete, as Benedict just said, well implemented. We have a good documentation, we have a good test in that, but we can still find some rooms for improvement. For example, improve the documentation because it will be used by all of the client teams, and so we have to be very specific in the documentation and in the API. We can add more tests because this is a very sensible cryptographic implementation, and so adding some fuzzing and some stuff is always welcome. Refactoring some code and some small potential avenue of speedup. For example, I am thinking about adding some SIMD optimization for this signature scheme, or adding like maybe more optimization to the Merkle tree or this kind of thing. So small speedup could be gained. Maybe also better parallelization and simplify the logic where possible, but basically this works and we are able to generate signature. We already have benchmark, and so this is not, let us say, our main focus. Then we have the Plonky3 implementation that is also very complete, used by all of the industry, of course, but we can have some gains on some very marginal parts, like SIMD instruction. For example, we made some good progress in the recent weeks. For example, adding SIMD for Mac, for Poseidon, or for specific like dot product stuff or multiplication, very low level stuff. We need also to think about how Fiat Shamir is handled, because right now it is not exactly the same as the one that we have in weir, so we have to have also discussion this afternoon about this. We haven't looked that much about like Merkle tree. I know that this is already very good in Plonky3, but we have also other implementations that are available. For example, I am thinking about some Facebook research repository where maybe we can find some tricks to optimize like data exchange in the Merkle tree operation and all of this. Maybe also more efficient matrix operation, transposition, and all of this. We don't do a lot of this, but in the leanVM repo, we have some matrix operation and some transposition. And for now, this is a bit more, a bit costly, so maybe we could have some improvement. On the DFT side, this is something that we use widely, but I think that this is already very, very good. So I don't think that we could gain that much, but this is to be explored. And then we have all the investigation on the side of multilinear, because right now, like Plonky 3 is univariate, and so there is no multilinear support, and so we have to add like a lot of primitives such as how to evaluate multilinear polynomials, how to implement sum check, how to implement WIM, so at Plonky 3, and of course test all of this. Then we have the WIR repo. So the core thing of WIR repo, of course, is the WIR implementation, so the round-by-round things that is handled by WIR. Inside we have a big building block that could be also considered as a primitive, that is the sum check. We can have outsource of optimization for the sum check. A lot of papers have been published. Jolt is a very good source of inspiration for that, because they are using sum check everywhere. Justin Taylor published a lot of papers, so, and also Angus Gruen within this room published the univariate skip trick, which can also be used, and some Bagad and Hall papers and all of this. What is very costly in WIR is about the first round. Why? Because this is where we are using the big polynomials, because as you know, like when you commit to a polynomial inside the PCS, you start with a very big polynomial, and then you fold it round after round, so the last rounds are almost free, but the first round are very costly, and so we can think about outsource of optimization to better understand what we are doing there, better parallelization strategy, better SIMD strategy. Yeah, outsource of strategy. We have also like the initial constraint of the WIRs that are then combined inside the big eval egg multilinear polynomials, and this step is very costly. Right now, we have done a bunch of work to do everything inside the PCS in the evaluation domain, meaning that what we done at the start is that we did everything in the evaluation domain, and each time we had to do an FFT, we transformed that into a coefficient domain, so it was like kind of a costly operation each time. So we found a trick to implement the DFT completely in the evaluation domain, to avoid having to have this kind of conversion at each round. So we currently maintain in the code a DFT that is basically like a copy and paste of the Plonky 3 DFT, but adapted to the evaluation domain. And we recently, Giacomo recently found like a nice select trick that could get us rid of this implementation. We are also implementing that right now. And we are also checking about how to make WIR as fast as possible and closer to Fry. So in the coming days, we should run like some benchmark in order to compare apple to apple with the same configuration for Fiat Shamir, same configuration for Merkle Tree, to compare WIR and Fry to see what's going on. And we have also like batch opening that is widely used by Emil in the leanVM, and that should be also upstream inside the WIR repo. And finally, we have like this leanVM code, that is the last repo that I mentioned. We can do all sorts of improvement there because the repo is quite new, handled by Emil like from like a couple of months. So we can improve speed as shown on the diagrams to reach the targets that we want. So this is basically 1,000 signature aggregated per second, and the 2-to-1 recursive aggregation is 200 and I noted 250 milliseconds, but Justin seems to mention even lower, like numbers always go low. We can also improve the compiler, fix the final design, because we always have open question and new stuff to discuss. So at the end, we'll have to fix the design, write it properly, and yeah, make it as simple as possible. We want also, as mentioned by Justin during this first talk, to provide some public goods. So it is important for us that all of our primitives, if possible, are upstream to Plonky 3, so that we can use them, but also all of the community, so that we have more eyes on the code, more optimization, and yeah, it can benefit all of you. Yeah, and then all of the classical stuff like peer review the code, add more tests, and yeah, clean up the code base. This is basically the work that we will focus on in the coming months. Yeah. This is all for me.
So you said there is a batch PCS WER implementation, is that right?
Yeah, because currently Emil is working like to move faster on the leanVM. He's working on a special fork of WER, let us say, and in this fork he implemented like the kind of a batch opening. This needs to be upstream into like the more well-maintained fork.
It's not perfect. It works, but it would not work if
currently, if you commit to polynomial and the second is much smaller than the first one, it will not work. But in the general setting, currently it works. But so it needs to be done more properly.
Yeah, and there is currently there are a bunch of open issues in the WER repo, and it is one of them.
Thank you.
Any other questions? If not, thanks again, Thomas.